Hello everyone, my name is Pratik Panda and I am a data science and business analytics intern at the Sparks Foundation. This is my second task, which is prediction using unsupervised ML. In this task, it is required to predict the optimum number of clusters and represent it visually. Now, let us know what is unsupervised ML and clustering. Unsupervised ML uses machine learning algorithms to analyze and cluster unlabeled datasets. These algorithms discover hidden patterns or data groupings without the need for human intervention. Now let's see what is clustering. Clustering is a data mining technique which groups unlabeled data based on their similarities and differences. Clustering algorithms are used to process raw, unclassified data objects into groups represented by structures or patterns in the information. Now let's know what is k-means clustering, which we will be using in this task. It is a common example of an exclusive clustering method where data points are assigned into k groups, where k represents the number of clusters based on the distance from each group's centroid. The data points closest to a given centroid will be clustered under the same category. Now, let's come to the task. Step 1, which is importing of the data. In this step, we will import the required libraries and dataset with the help of pandas library. As you can see, we have imported the required libraries like NumPy, Matplotlib, Pandas, sklearn, and sklearn.cluster. To ignore the warnings, we have imported the warnings as WG, and we are using the dot filter warnings. Now we will read the Iris dataset. For reading the dataset, I have already saved the dataset on the same path in which my file this tsf task2 is saved. So I don't have to give the path name. Directly I have given the file name, which is iris.csv. We read the dataset by using the pd.read, and it is stored in a variable df. Now let's know what is exactly the iris dataset. The IRIS dataset is a multivariate dataset introduced by the British statistician and biologist Ronald Fisher. You can see here the dataset consists of a set of 150 records under the five attributes: sepal length, sepal width, petal width, and species. These are the three species which are here. First one is Iris setosa. Second one is Iris versicolor, and third one is Iris virginica. Now in step 2 we will visualize the dataset. Df.sep gives us the number of rows and columns. There are 150 number of rows of data and 6 columns of data. Df.head gives us the first 5 rows of the data, as you can see here, 0, 1, 2, 3, 4, and df.tel gives us the last 5 data rows, which is as you can see here, 145, 146, 147, 148, and 149. Df.columns gives us the column names, which are id, sepal length, cm, sepal width, petal length, petal width, and species, as you can see here. To know the species, we are using dot unique here. To check what unique species we have, we can use give dot unique in species to see the 3 species which are shown in the output as Iris setosa, Iris versicolor, Iris virginica. df dot info and df dot describe are used to get the information about the dataset. As it is an unsupervised ML, we will drop 2 columns, ID and species, and then store our dataset in iris underscore df, as you can see here. If you can check the dataset by using dot head, you can see here the spaces and ID columns are dropped, and we have only the four columns which we will use. Step 3 is finding the optimum number of clusters. Before clustering the data using k-means, we need to specify the number of clusters. In order to find the optimum number of clusters, there is various methods available like Silhouette coefficient and elbow method. Here the elbow method is used. Now I am going to give you a brief about the elbow method. In this method, the number of clusters varies within a certain range. For each number within cluster, sum of square value is calculated, which is the WCSS value is calculated and stored in a list. These values are then plotted against the range of number of clusters used before. The location of the 2D plot indicates the appropriate number of clusters. Now we are calculating the WCSS value and plotting it against the number of clusters. As you can see here, by using a for loop, we are calculating the WCSS value and plotting it against the number of clusters. As you can see here, the number of clusters is in the x-axis and WCSS value is in the y-axis. Uh, what this method tells us that after the point when it tries to become constant, as you can see here, the cursor here, this at this point, after this point, the line is becoming constant. After the point 3, which is the point 3, the graph appears to be constant. So we will be using the number of clusters as 3. Now comes the step 4, applying k-means, that is clustering of the data. This is done by importing the k-means module from the sklearn.cluster. And then in step 5, we will be visualizing the clusters in 3 classes with different colors. As you can see, the first species Iris setosa is in red color, Iris versicolor in blue, and Iris virginica in green. And here we have plotted the cluster elements, and we get here the yellow points are the centroids, as you can see in this graph. The red one is the Iris setosa, blue ones are the Iris versicolor, and the green ones are the Iris virginica. And so we have achieved the purpose of this task. Thank you.